Arc welding is a type of welding process that uses an electric arc to create heat to melt and join metals. The power supply can create an electric arc between a consumable or non-consumable electrode and the base material to melt the metals at the welding point. They can use either direct or alternating current, and consumable or non-consumable electrodes. The welding area is usually protected by some type of shielding gas, vapor, or slag. Arc welding processes may be manual, semi-automatic, or fully automated. First developed in the late part of the 19th century, arc welding became commercially important in shipbuilding during the Second World War. Today, it remains an important process for the fabrication of steel structures and vehicles. Here are some of the most common types of arc welding. Shielded metal arc welding, also known as manual metal arc welding, flux shielded arc welding, or stick welding. This process uses a consumable electrode coated in flux to lay the weld. Gas metal arc welding, commonly referred to as MIG welding, uses a wire feeding gun that feeds wire at an adjustable speed and sprays an argon-based shielding gas or a mix of argon and carbon dioxide over the weld puddle to protect it from atmospheric contamination. Gas tungsten arc welding, also known as TIG welding, uses a non-consumable tungsten electrode to produce the weld. The weld area is protected from atmospheric contamination by an inert shielding gas, and the filler metal is normally used, though some welds, known as autogenous welds, do not require it. Flux-cored arc welding is similar to MIG welding, but it uses a special tubular wire filled with flux. It can be used with or without shielding gas, depending on the filler. Submerged arc welding involves the formation of an arc between a continuously fed electrode and the workpiece. A blanket of powdered flux generates a protective gas shield and a slag, which protects the weld zone. Plasma arc welding, similar to TIG welding, uses an electric arc between a non-consumable electrode and the workpiece, but the electrode is positioned within the body of the torch, so the plasma arc is separated from the shielding gas envelope. Each type of arc welding has its own advantages and is suited to specific applications. The choice of process depends on the type of metal, the thickness of the material, the desired quality of the weld, the production efficiency, and the cost.